All right, everyone, hello and welcome. Have you ever stopped to think about how we can be so sure that the angles in a triangle always add up to 180 degrees? Or how architects can design these huge, perfectly structured buildings? Well, it all boils down to a set of really simple but super powerful rules. Today, we're going to unlock that code of shapes, the very foundation of geometry that was laid down by a genius named Euclid. So let's dive right in. Okay, so here's our game plan for today. First up, we're going to take a quick trip back in time to see why this old-school geometry is still so important. Then, we'll break down Euclid's basic building blocks. After that, we'll see exactly how to use these rules to solve a problem. The kind you'll see in your exam. And we'll wrap up with a quick recap and some tips to really help you nail it. All right, first up, why study old geometry? I know, you might be thinking, sir, why are we studying ideas from over 2,000 years ago? It seems ancient, right? But trust me, as we're about to see, these concepts are the absolute foundation of all the math we use today. You see, geometry didn't just start in some classroom. Nope, it began with real everyday problems. Imagine this. In ancient Egypt, the Nile River would flood every single year, and they needed geometry to measure and redraw all the property lines. In ancient India, it was crucial for planning entire cities and building these incredibly precise religious altars. But then the ancient Greeks came along and started asking a totally new kind of question. Why? Why does this actually work? And let me tell you, that one little question changed everything. It turned geometry from just a how-to guide into a powerful system of logic. So you can really think of it like this. The early geometry in places like Egypt and India was all about how-to. It was a set of practical rules that gave you results. But Greek geometry, that was all about the why. They weren't happy just knowing that a rule worked. They wanted to prove, with pure logic, why it absolutely had to be true. And this brings us to the man of the hour, Euclid. Now here's a fun fact. He didn't actually invent all of geometry himself, but what he did was absolutely incredible. He collected all the geometric knowledge of his time, everything that was known, and organized it into one logical, beautiful system in his book, Elements. Seriously, think of it as the ultimate rulebook for geometry. It's so good, it's been the go-to textbook for over 2,000 years. Amazing, right? Okay, let's move on to Euclid's building blocks. So how did he do it? How did he build this massive system of logic? Well, he started with a few super-duper basic ideas. I like to call them the atoms of geometry. These tiny, fundamental pieces that everything else is built on. And you're going to see, they're simpler than you think. All right, first up, we have the point. Now, Euclid's definition is a little strange. A point is that which has no part. What does that even mean? Well, just think of it as a perfect, tiny dot that marks a location. It has a position for sure, but it has no dimension, no length, no width, nothing. It's just there. It's the most basic starting block we have. Next up, we have a line. Euclid's definition for this was a breadthless length. Again, kind of a weird phrase, right? It just means it has length, but absolutely no thickness or width. It's like the path between 2 points. You can even imagine it as a string of countless points all lined up perfectly in a row. And finally, we have a surface. A surface is just a flat space that has length and breadth. But, you guessed it, no thickness. A perfect, flat sheet of paper is a great way to think about it. And what are the edges of that paper? Well, they're lines, of course. Okay, but wait a minute. This brings up a really common question, and it's a fantastic one. If Euclid is giving us all these definitions, why do mathematicians today call these undefined terms? It sounds like a contradiction, right? Well, here's why. If you try to define every single word, you get stuck in an endless loop. Think about it. If a point has no part, you'd have to ask, well, what's a part? Then you'd need a definition for that, and you'd have to define the words in that definition. See? It never ends. So to avoid this, mathematicians just agree that a few simple ideas, point, line, plane, are our intuitive starting points. We all kind of know what they are, so we just accept them and build from there. All right, section 3, axioms and postulates. So, now we have our basic building blocks, right? Our atoms. But now we need some rules for how they can interact with each other. That's where Euclid's famous axioms and postulates come in. You can really think of them as the official rulebook for the game of geometry. Let's solve this together. Okay, so Euclid split his rulebook into two main types, axioms and postulates. Here's the difference. Axioms are like universal truths. They apply to everything, not just math. For instance, the whole is greater than the part. That's true if you're talking about a pizza or a number, right? But postulates, those are the special rules that apply only to geometry. They're the basic rules for how we can draw and work with shapes. Let's take a look at a few of his key axioms. Honestly, these are just common sense written down. Like this one. Things which are equal to the same thing are equal to one another. Basically, if A equals B and B equals C, then of course A has to equal C. Or how about if equals are added to equals, the wholes are equal? Again, makes perfect sense. We use these ideas every single day without even thinking about them. And here are his 5 famous postulates, the specific starting rules for geometry. The first 4 are super intuitive. 1. You can draw a straight line between any 2 points. Check. 2. You can extend any line segment as far as you want. Got it. 3. You can draw a circle with any center and any radius. Easy enough. And 4. All right angles are equal to each other. Makes sense. The 5th one, well, the 5th one is a bit more famous and wordy, but it's really just the rule that defines parallel lines. And that's it. These 5 simple rules are all you need to build the entire world of geometry. You can totally do this. Okay, now for the fun part. Let's see these axioms in action. We're going to use these rules to solve a problem, step by step. This is exactly how you'll approach proofs in your exam, so let's do one together. Okay, here's the problem we need to solve. If A, B, and C are 3 points on a line, and B is sitting between A and C, then we have to prove that the length of AB plus the length of BC is equal to the length of AC. Now, your first reaction is probably, well, that's completely obvious. And you're right, it is. But in geometry, obvious isn't good enough. We have to prove it using our official rulebook. First things first, what do we always do in geometry? We draw a picture. So let's visualize what the problem says. We just draw a straight line. We put point A at one end and point C at the other. And then we stick point B somewhere in between them. Simple as that. All right, now let's build the proof. Step 1 is our observation. Just by looking at the figure, we can see that the segment AB, together with the segment BC, perfectly covers or coincides with the entire segment AC, right? Step 2, we need a reason from our rulebook. And we have one. Euclid's axiom 4 says that things which coincide with one another are equal to one another. And there it is. Step 3 is our conclusion. Since AB plus BC coincides with AC, they must be equal. Therefore, we can say with absolute certainty, AB plus BC equals AC. And we're done. See? A perfect logical proof. Okay, great job, everyone. Let's quickly recap the most important things you need to take away from this, especially for your exams. Let's lock in these key ideas. All right, let's review our key vocabulary. Remember, we have our undefined terms. Those are the basic starting ideas like point, line, and plane. Then we have the rule book, the axioms, which are universal truths, and the postulates, which are the specific rules for geometry. And finally, we have theorems. Those are the statements that we actually prove are true by using all the other stuff. It's a pyramid of logic. And here is a huge exam tip. Please remember this. A proof is like telling a logical story. For every single step you write down, you must give the reason why it's true. And where do those reasons come from? Yep, usually from our list of axioms and postulates. Don't just state a fact, you have to state why it's a fact. That's absolutely crucial. And that wraps up our introduction to Euclid's geometry. It's such a powerful idea, isn't it? That all of these complex shapes and proofs can be built from just a handful of simple common sense rules. It kind of makes you wonder, what other big, complex systems in the world are also built on a few simple rules? Something to think about. Keep practicing, keep asking why, and you'll get the hang of it in no time. Great work today, and I'll see you next time.